Now we are going to look at horizontal stretches and compressions of graphs. These are in the form of y equals f of, and we replace the x with a times x on the inside of the parentheses. What happens to the graph is you multiply each x coordinate of y, the function y, by 1 over a. So 1 over a becomes the multiplier, not a. Now, the graph will stretch if a is between 0 and 1. It stretches horizontally if a is between 0 and 1. This is a stretch. And it will stretch by a factor of a. Now, let's assume that a is how about 1/3? Okay. What happens is with 1/3, it's going to really multiply everything by 1 over 1/3. So if 1 over 1/3, that means it really stretches it by 3. So I take each x coordinate times 3. Means I'm going to have to make this longer just for this graph. 6, 7, 8, 9. -3 times 3 gives you -9, which is way out here. So we have the point -9, comma 2. And down here, when we take 0, 1, we take 3 times 0, and we get 0. So this point stays. And then 2 times 3 is 6. 2, 3, 4, 5, 6. We have the coordinates 6, comma 1. So when a is a fraction, what it really does is it stretches it by 1 over a. Okay, a factor of 1 over a. Now, what if a were a whole number? I say, what if a were 2? So, what if we were finding y equals f of, in place of a, I'm going to put 2x. Remember, this really is, we take 1 over our a. Okay, so that means we take 1 over 2. This would be a compression. So we get a compression when a is larger than 1. Our a was 2. We take each x coordinate by 1 over 2. So 1 over 2, 1/2, times each x coordinate. -3 times 1/2 is -3/2, or -1.5, comma 2. Then we take 0 times 1/2. We still get 0. Then we take 2 times 1/2, and we get 1. So we have the point 1, comma 1. If I connect my dots, there we have our horizontal compression. Now let's look at our stretch, because I forgot to connect my dots. So if I connected the dots here, you notice it has stretched this out horizontally. Neither one of these two graphs maintain the same size or shape whenever we have a number a in front of the x. So we have f of ax.